Let us go for another example of Taylor series expansion. So obtain the Taylor series expansion of f of z equal to e power z by z into z plus 1 about z equal to 2. So the given function f of z equal to e power z by z into z plus 1. We have to expand in terms of z minus 2. We have to write the expansion in powers of z minus 2. So for that, let f of z equal to e power z by z into z plus 1. Z can be written as z plus 2 minus 2. So we have to write the expansion in terms of z minus 2. For that, first write z minus 2 plus 2 and plus 1 can be written as 3 minus 2 or minus 2 plus 3. So the both terms should have z minus 2. Because we want to write in powers of z minus 2. So in the denominator, we are writing the given terms into z minus 2 terms. So for that, z equal to z minus 2 plus 2 and z plus 1 equal to z minus 2 plus 3. On the numerator e power z, here also we have to make z minus 2. For that, e power z can be written as e power z minus 2 plus 2. That is e power z minus 2 into e power 2. E power 2 common out. Then e power 2 into e power z minus 2 by, in term of z minus 2 plus 2, 2 common out. If you take 2 common, then that becomes 1 plus z minus 2 by 2. In the second term, 3 common out. That becomes 1 plus z minus 2 by 3. So e power 2 by 6 into e power z minus 2 into the denominator 1 plus z minus 2 by 2 can be taken to the numerator. Then it becomes 1 plus z minus 2 by 2 whole power minus 1. Here also 1 plus z minus 2 by 3 whole power minus 1. So this expansion is valid for mod z minus 2 by 2 less than 1, because 1 plus x whole power minus 1 is valid for mod x less than 1. 1 plus x whole power minus 1 is valid for mod x less than 1. Similarly, 1 plus z minus 2 by 2 whole power minus 1 is valid for mod z minus 2 by 2 less than 1. And 1 plus z minus 2 by 3 whole power minus 1 is valid for mod z minus 2 by 3 less than 1. So this can be written in the as e power 2 by 6 into e power z minus 2 means sigma n equal to 0 to infinity z minus 2 whole power n by factorial n. E power x equal to sigma n equal to 0 to infinity x power n by factorial n. E power x equal to sigma n equal to 0 to infinity x power n by factorial n. Similarly, e power z minus 2 equal to sigma n equal to 0 to infinity z minus 2 whole power n by factorial n. This is 1 plus x whole power minus 1. That means, otherwise you can't write this sigma notation. You can go to the expansion directly. E power z minus 2, e power x expansion. 1 plus x by factorial 1 plus x square by factorial 2 plus x cube by factorial 3, like this. You can write directly this expansion without using this sigma notation. So e power z minus 2 is 1 plus z minus 2 by factorial 1 plus z minus 2 whole square by factorial 2 plus z minus 2 whole cube by factorial 3 plus and so on. Similarly, 1 plus z minus 2 by 2 whole power minus 1, that is 1 plus x whole power minus 1 expansion. 1 plus x whole power minus 1 expansion is what? 1 minus x plus x square minus x cube, like that. 1 minus x means z minus 2 by 2. 1 minus x, 1 minus z minus 2 by 2 plus x square, z minus 2 by 2 whole square minus x cube, z minus 2 by 2 whole cube, like this. Similarly, second last term. Last term 1 plus z minus 2 by 3 whole power minus 1. That is also 1 plus x whole power minus 1 expansion. 1 minus x plus x square and so on. So 1 minus z minus 2 by 3 plus z minus 2 by 3 whole square minus z minus 2 by 3 whole cube, like this. So without using sigma notation, you can directly go to the expansion. Now, so first one e power 2 by 6 into, this is e power z minus 2. Ante e power x expansion. 1 plus x by factorial 1 plus x square by factorial 2, like this. 1 plus z minus 2 by factorial 1 plus z minus 2 whole square by factorial 2, like this. Second one is 1 plus x whole power minus 1 expansion. Third one is also 1 plus x whole power minus 1 expansion. Now, multiplying the first two terms, e power 2 by 6, write it as it is. Multiply the first two terms. 1 times 1, 1. 1 times z minus 2 by 2, z minus 2 by 2. 1 into z minus 2 whole square by 4, z minus 2 whole square by 4. And so we can't multiply all the terms. So for example, we have taken 3 terms. There are infinite series. Similarly, take the second term, z minus 2 by factorial 1 into 1. That is z minus 2 by 1. We can't multiply all the terms. We are multiplying only 2 terms here, 3 terms here. First, 1 times 1, 1. 1 times z minus 2 by 2, 2. 1 times z minus 2 whole square by 4, z minus 2 whole square by 4. Next, go to the second term, z minus 2 by factorial 1 into 1. Take z minus 2 by 1, z minus 2 by 1 into z minus 2 by 2. That minus z minus 2 whole square by 2. Next, z minus 2 by 1 into z minus 2 whole square by 4. That is z minus 2 whole cube by 4. 1, okay. Z minus 2 by 1, okay. Z minus 2 whole square by 2. Next, z minus 2 whole cube by 4. This is z minus 2 whole cube by 4. The last term is, there is a mistake. First, multiply 1 into first 3 terms in the second bracket. Next, 1 into first 3 terms in the second bracket. Z minus 2 by 1 into 1, z minus 2 by 1. Z minus 2 by 1 into z minus 2 by 2. That is z minus 2 whole square by 2. Z minus 2 by 1 into z minus 2 whole square by 4. Otherwise, no, they are taking next z minus 2 whole square by factorial 2 into 1. So z minus 2 whole square by 2, like this. The last term, first write as it is. Next, multiply 1 into the terms in the 2 brackets. First 1 into 1, 1. First simplify these terms. 1 into 1, 1. Z minus 2 by 1 minus z minus 2 by 2 plus z minus 2 by 1 minus z minus 2 by 2. If you common out z minus 2, 1 minus 1 by 2, half. That is z minus 2 by 2. This is not z. This is z minus 2 by 2. Next, common out z minus 2 whole square. If you common out z minus 2 whole square, 1 by 4 minus 1 by 2 plus 1 by 2. So, minus 1 by 2 plus 1 by 2 cancel. Z minus 2 whole square by 4 remains. So, write the last term as it is. Next, multiply the two terms. 1 into 1, 1. 1 into z minus 2 by 3, z minus 2 by 3. 1 into z minus 2 whole square by 9, z minus 2 whole square by 9. Next, z minus 2 by 2 into 1, z minus 2 by 2. Z minus 2 by 2 into z minus 2 by 3. Z minus 2 whole square by 6. Next, z minus 2 whole square by 4 into 1. Z minus 2 whole square by 4. So, like this you multiply. So, e power 2 by 6 into 1 plus. Now, z minus 2 common out. 1 by 2 minus 1 by 3, 1 by 6. Get z minus 2 by 6. z minus 2 whole square common out. 1 by 4 minus 1 by 6 plus 1 by 9. So by simplifying 7 by 36 you will get. So this is the expansion of Taylor's series in terms of z minus 2. The next one is f of z equal to 1 by z square minus z minus 6 about z equal to minus 1 and about z equal to 1. So we have to write the given function in terms of z plus 1 and z minus 1. About z equal to minus 1 means in terms of z plus 1, in powers of z plus 1. About z equal to 1 means in powers of z minus 1. So first, for the first case, you have to write all the series in powers of z plus 1. For that, first let f of z equal to 1 by z square minus z minus 6, that is z minus 3 into z plus 2. By taking the partial fractions, a by z minus 3 plus b by z plus 2, we will get 1 by 5 into 1 by z minus 3 minus 1 by z plus 2. Now, each term z minus 3 can be written as z plus 1 minus 4. You have to write z plus 1 in each term. For that, you can simplify z minus 3 as z plus 1 minus 4. Z minus 3 can be written as z plus 1 minus 4. Similarly, z plus 2 can be written as z plus 1 plus 1. Anyhow, you have to get z plus 1. Because we have to write the expansion in terms of z plus 1. So, in the denominator, you should have z plus 1. Now, in the first term, minus 4 common out. Minus 4 common out. So, that is equal to minus 4 common out. Then we will get 1 minus z plus 1 by 4. By taking in the numerator, 1 minus z plus 1 by 4 whole power minus 1. In the second term, 1 is already there. So, 1 plus z plus 1 whole power 1 can be written as whole power minus 1. Taking into the numerator, it would become 1 plus z plus 1 whole power minus 1. So, that is equal to minus 1 by 20. 1 by 5 is common. 1 by 4 into 5 minus 1 by 20. This is the in the form of 1 minus x whole power minus 1. 1 plus x square plus x cube and so on. And 1 plus x means z plus 1 by 4 plus x square. Z plus 1 plus 1 by 4 whole square plus z plus 1 by 4 whole cube, so on. Next, minus 1 by 25. Here we have 1 by 5 common. Here also we have 5. No. Okay, no, 1 by 5. Already 1 by 5 is taken to 2 terms. Now minus 1 by 5 into 1 plus x whole power minus 1. 1 minus x plus x square minus x cube, like that. 1 minus x means z plus 1. 1 minus z plus 1 plus z plus 1 whole square and so on, like that. So that is equal to. So now we have written the given function f of z in powers of z plus 1. Z plus 1 by 4 plus z plus 1 whole square by 16 plus z plus 1 whole cube by 64, like this. So this is the required series. This series is valid in mod z plus 1 by 4 less than 1 or mod z plus 1 less than 1, because 1 minus x power minus 1 is valid for mod x less than 1. So here in the x place of x we have z plus 1 by 4. So mod z plus 1 by 4 less than 1. In the second term, in the place of x we have z plus 1. So mod z plus 1 less than 1. You can write sigma notation or you can leave this as it is in the expansion. And next case is we have to write f of z in powers of z minus 1 about z equal to 1. That means in powers of z minus 1. So now you have to write the denominator in terms of z minus 1. So Z minus 3 can be written as f of z means 1 by 5 into 1 by z minus 3 minus 1 by z plus 2. Now z minus 3 can be written as z minus 1 minus 2. That is z minus 3. Z plus 2 can be written as z minus 1 plus 3. So z plus 2 means z minus 1 plus 3. Now taking into the negative minus 2 common out in the first term, 3 common out in the second term. If you common out minus 2, then you will get 1 minus z minus 1 by 2. In the second term, 3 common out, you will get 1 plus z minus 1 by 3 whole power minus 1. The first term is 1 minus x whole power minus 1 expansion. The second term is 1 plus x whole power minus 1 expansion. So you can expand the terms as it is and you can leave them as it is. Here the valid reason is mod z minus 1 by 2 less than 1 and mod z minus 1 by 3 less than 1. So the next problem is expand log z by Taylor series about z equal to 1. Log z about z equal to 1. So let us go to the alternate method. This is simple one. So about z equal to 1 means put z minus 1 equal to w. So z equal to 1 plus w. Put z minus 1 equal to w. So z equal to 1 plus w. Log z equal to log 1 plus w. Log 1 plus x series expansion. Log 1 plus x. X minus x square by 2. There is no factorial. Only x square by 2 plus x cube by 3 plus and so on like this. For mod w less than 1. So log 1 plus w means w minus w square by 2 plus w cube by 3 minus w power 4 by 4 and so on. W means z minus 1 minus z minus 2 whole square by 2 plus z minus 2 whole cube by 3. Sorry, z minus 1 whole cube by 3 plus and so on. The plus and minus are changing alternatively. So you have to put minus 1 whole power n minus 1 for the nth term. Minus 1 whole power n minus 1 into w power n by n. So z minus 1 power n by n for mod z minus 1. W means z minus 1 less than 1. Otherwise, you can go to the definition of Taylor series. The first method. The definition of Taylor series is f of z equal to f of a. If you know the log z expansion, directly you can use this method. If you don't know the log z expansion, then you have to go to the definition. F of z equal to f of a plus z minus a into f dash a plus z minus a whole square by factorial 2 f double dash a and so on. About z equal to 1 means put a equal to 1. So f of 1 plus z minus 1 f dash 1 plus z minus 1 by factorial 2 f double dash 1 and so on. F of 1 is f of z log z. F dash z 1 by z. About f dash 1 1 by 1 1. F double dash z. So the different derivative of 1 by z is minus 1 by z square. F double dash 1. Put z equal to 1. So that is equal to minus 1 by 1 minus 1. F triple dash z. So again differentiating f double dash z. 1 by z square minus 1 by z square differentiation minus 1 into minus 2 by z cube. That is 2 by z cube. So f triple dash 1 2 by 1 that is 2. F4 of 1 minus 6. You can find the derivatives like this and I can write the series. This is also a simple method. If you don't know the expansion, you can go to the Taylor series definition directly. F of z equal to f of a plus z minus a into f dash a plus z minus a whole square by factorial to f double dash a, so on. We can't write all the terms So for example, we will take the derivatives up to f triple dash or f4. So put a equal to 1, f of 1 plus z minus 1 f dash 1 plus z minus a 1 whole square by factorial to f double dash 1, like this. Now you have to find f dash 1, f double dash 1, f triple dash 1, so on. For that, let f of z equal to 1 by z, f dash z equal to, f of z equal to log z, f dash z equal to derivative of log z 1 by z, f double dash z, the derivative of 1 by z, 1 minus 1 by z square, the derivative of minus 1 by z square, 2 by z cube, the derivative of 2 by z cube, minus 3 by z power 4. Put z equal to 1 in the derivatives, then you can write the derivative values in the expansion. This is also another method of expansion of log z. So these are the examples of Taylor series theorem, students. Okay, thank you.